Hello class, today we're going to be talking about section 3.1, the inverse of sine, cosine, and tangent functions. The first thing we're going to talk about is some properties for sine, and so sine inverse of x simply means that x is equal to sine of y. So really, when we have y is equal to sine of x, all we've done is we've switched x and y. And so there's some restrictions that come with that, where negative 1 is less than or equal to x, which is less than or equal to 1, and negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2. So these are restrictions that we're going to use in order to be able to solve some problems. So let's go through an example so you guys can see. And so this first example is to find sine inverse of 1. And so what we'll do is we're going to let theta equal sine inverse of 1. And the inverse of sine inverse is sine, so if I take sine to both sides, sine inverse of sine of sine inverse of 1 will get rid of the inverses, and so we'll get sine of theta is equal to 1. And so to find where that is, we need to remember from the unit circle where sine is 1. And so we know that that occurs at pi over 4, and it also occurs at a negative 5 pi over 4. But we see that the restriction that we have says that we have to be between negative pi over 2 and pi over 2. So really what we could do is change this to be called negative pi over 2, and so this is the area that it has to fall under. It has to fall under the first and the fourth quadrant, and so that means that our answer is going to be pi over 4. So we know our theta here is pi over 4, or our answer for our problem is pi over 4. Okay. Another example to look at is sine inverse of a negative 1/2. And so again, we'll follow those same steps. We're going to let theta equal sine inverse of a negative 1/2. Taking the inverse of each, or taking sine of each side, we're going to get sine theta is equal to a negative 1/2. And so where is sine equal to a negative 1/2? Well, again, we're restricted to the first and fourth quadrant, and so we know that at pi over 6, we know that sine is equal to 1/2. So then sine of pi over 6 would be 1/2. So then at a negative pi over 6, sine of negative pi over 6 would be equal to a negative 1/2. It's below the x-axis, and so we know that theta is a negative pi over 6, and so our answer is a negative pi over 6. Okay, we also are going to want to know how to use a calculator with some of these problems, and so a problem like this one, where sine inverse is 1/3, we don't know what the answer would be. And so in a TI 84, the first thing that you're going to want to do is you're going to want to hit the mode and make sure that you are in radians. Once you're in radians, the next thing you'll do is you're going to go hit the second and then sine. That will yield sine inverse. This is what you should see on the calculator. And then you'll type in 1 divided by 3, and that should give you 0.3398, which is approximately 0.34. And so if we were to do it like we did before, we'd let theta equal sine inverse of 1/3, then sine theta would be 1/3, and so we know that sine theta of 1/3, the theta would end up being 0.34. Because it's in radians, we don't get some number that's satisfying for us like we've done in the past. Okay, but again, this is using a TI-84, which is a calculator that I strongly recommend you all have, especially if you're going on forward with your math courses. Okay, now we're going to be dealing with the properties for the inverse function. And so we know that f inverse of f of x would be sine inverse of sine of x. And since they're inverses of each other, we're going to get x, but there is a restriction for this one. And the restriction is that we need to be between negative pi over 2 and pi over 2. So we need to be either in the first or the fourth quadrant. If we do the function of the inverse function, then that's going to be sine of sine inverse of x, which again will be equal to x. But here the restriction is that we need to be between negative 1 and 1. So those are some of the properties that you need to know and remember. Notice that with the sine inverse is inside the parentheses like this, our restriction is between negative 1 and 1. And when we have sine in the inside of the parentheses, our restriction is from negative pi over 2 to pi over 2. Okay. So in this example that we have here, we see that the restriction is going to be from negative pi over 2 to pi over 2. And since they're restrictions of each other, we're going to get pi over 8. So that's pretty satisfying. It's easy. Now, this one here, this is supposed to be reversed. This is supposed to not be inverse, and this is supposed to be inverse. Now, pi over 8, when the inverse is on the inside, so let me rewrite that so it looks clean for you guys. It should be sine of sine inverse of pi over 8. And what's going to happen here is pi over 8, if we use a calculator, would be 0.39. And that clearly falls within our negative 1 to 1 area. And so this will be equal to pi over 8 also. So I'll do this. I'll highlight it so you guys can see. So since sine is on the inside, I'm going to use the blue. And since sine inverse is on the inside, my restriction is the red or pink color for the pi over 8. So like I said, pi over 8 was equal to 0.39. And so it would work with this one in the pink case, and then pi over 8 is in fact between negative pi over 2 and pi over 2. So it would also work with this one in this case. Okay. Let me show you another example. So in this case here, I'm going to work on the inside piece. So I'm going to say, all right, let's let theta equal sine inverse of 1/2. And so just like we've done in the previous examples, sine theta is equal to 1/2. And here we know that sine theta of 1/2 is pi over 3 from our unit circle. And but that's just the inner piece. So all of that work that we just did is for this inside. And so the problem then ends up being sine of pi over 3. And sine of pi over 3 is 1/2. So this is 1/2. It's just another way of looking at how to attack these problems. Since sine inverse was the inside function, we would have used the pink. Is it between -1 and 1? Yes, of course. And so the answer would have been just the parentheses inside the 1/2. Okay. Now let's look at cosine. Cosine then is y is equal to cosine inverse of x, which means that x is equal to cosine of y. Again, it's the switching of x and y. And so the restrictions here are where -1 is less than or equal to x is less than or equal to 1, and that our restriction for y is from 0 to pi. So the restriction here is a little bit different, so please pay attention to these carefully. So when we solve this first problem, we're going to do very similar to the sine inverse problems that we did. We're going to let theta equal cosine inverse of 0, and then taking cosine of both sides, we can get cosine theta is equal to 0. And then we need to look. So if we look at a graph, we're going from 0 to pi is our restriction. Where is cosine theta equal to 0 in quadrants 1 and 2? Well, the answer is at pi over 2. So then we end up getting theta is equal to pi over 2. And so the answer here is pi over 2. All right, our next example, it's cosine inverse of a negative square root of 2 over 2. If theta is equal to cosine inverse of radical 2 over 2, then cosine theta is equal to well, that should be a negative there, negative radical 2 over 2. And so when we look at it, again, restrictions are first and second quadrant, and cosine refers to x, so we know that radical 2 over 2 is at pi over 4, but it would also be the same x value at 3 pi over 4, and with opposite sign, and so we end up getting our theta to be 3 pi over 4, and so this is 3 pi over 4. Okay. Some properties for this would be f inverse of f of x is equal to cosine inverse of cosine of x. That's going to be x, and then again there's a restriction there of being between 0 and pi, and then when we switch our composition, the restriction is going to be a little different also, and here the restriction is going to be from -1 to 1. Okay, so using this new information that we have, let's see if we can solve this first problem. Now, something very neat here is we see that we're going to be between 0 and pi, but -2 pi over 3 isn't in that interval. So -2 pi over 3 is not in the interval. So really we're kind of stuck, right? But then we remember something about cosine, and we remember that cosine, but since cosine is even, we know that cosine of a -2 pi over 3 is equal to cosine of 2 pi over 3. And cosine of 2 pi over 3 is in the interval. So what we could do then is address this problem by saying we can find this value by changing it just a little bit and making it now positive. And so from here, this ends up telling us that our answer is 2 pi over 3. But notice that it's 2 pi over 3 positive, not negative, because of the restriction on where we're at. Okay. The next example we see here is we're in the inverse. So the inverse was from -1 to 1. Negative 0.04 is in that interval, and since it falls in that interval, our answer is very simply that. Okay. Now, cosine inverse, remember, is that interval from -1 to 1. Pi is 3.1415928, continuing on forever and ever. That is outside of that domain that we have of -1 to 1, and so this will not be defined. We can't do it because it's not in the interval that we need. All right. The next thing that we're going to talk about is the tangent function and how to address it. And so the tangent inverse is going to be y is equal to tan inverse of x, which means x is equal to tan of y. And our restrictions are where we're going to go from negative infinity to positive infinity for x, and from negative pi over 2, not equal, strictly less than y, which is strictly less than pi over 2. Okay, so looking at this problem, again, we attack it like we did sine and cosine. And from here, we're going to get tan of theta is equal to 1, where is tan of theta equal to 1 between negative pi over 2 and pi over 2, and that occurs at pi over 4. Again, like I said to you, please have reference of your unit circle. It will be very, very, very useful. Something that you'll really want to have. But again, at pi over 4, tan of that angle will be 1. At negative pi over 4, tan of that value would be -1. Okay, in our next example, we're going to let theta equal tan inverse of a negative radical 3. So then tan theta is going to be equal to a negative radical 3. And again, based off of the unit circle, we know that this occurs at a negative pi over 3. So looking at this thing, I always refer everything in the first quadrant and then reference to other places. And so I know that at pi over 3, we're going to get that radical 3, and so down here we're going to have to use the reference negative radical 3, which will be that negative, or negative pi over 3, which will give us that negative radical 3. So there's that. Okay. Now this one, the inverse of f of x is going to be equal to tan inverse of tangent of x, and the restriction here is going to be from negative pi over 2 to pi over 2, and then f of inverse of x is going to be tangent of tangent inverse of x, and the restriction there is going to be from negative infinity to infinity. Okay. Let's try a problem. And here we're getting the restriction. We're getting a restriction. So the restriction here is this problem tells us we're from negative pi over 2 to pi over 2. And it's saying find the inverse function. And so to find the inverse function of this, what we're going to do is I'm going to rewrite it as y is equal to 2 sine of x minus 1. And then I'm going to switch x and y. So switch x and y. And so I'm going to get x is equal to 2 sine of y minus 1. And then I'm going to solve for y. So the first thing I need to do is add 1 to each side, which will give me x plus 1 is equal to 2 sine y. Then divide by 2 each side, which will give me sine of y. And now we know to get rid of sine, we can go by sine inverse. So sine inverse of x plus 1 over 2 is my y. I'm rewriting that y now to be f inverse of x. And that's going to be sine inverse of x plus 1 over 2. And that is the inverse function of the given problem that we've had. Okay. One last example, and we'll have section 3.1 done. Now here we're going to find the inverse of this, and so what we're going to do is I'm going to solve. So I have 3 sine inverse of x is equal to pi, and so to get sine inverse alone I need to divide by 3. And so I'm going to get sine inverse of x is equal to pi over 3. And then taking sine of each side, I'm going to get x is equal to sine of pi over 3. And so in this problem we're going to solve for it. And since we're solving for it, x is equal to sine of pi over 3. At sine of pi over 3, we just did a problem like this, and we know that that's going to be x value is going to be equal to radical 3 over 2. I hope you found this beneficial, and if you have any questions, as always, feel free to contact me. All the best.